So a question like this, normally it's just sketch and you're just using all your tools. So they've scaffolded it here to say, you know, to help you do it. But really, if we just look at this curve, what are the kind of efficient tools we can use to graph it? So to start with, we would look at it and go, oh, look, you cannot have x equals 0 and you cannot have x equals 4. So we've got vertical asymptotes at those points. So x equals 0 is a vertical asymptote, I do it in blue. Also x equals 4, let's put it over here, is, actually I'll put it here, is a vertical asymptote. So x equals 0 and x equals 4. So they're handy things to know straight away. The other thing is to look at, clearly it can't be even or odd function here. That's handy. And the other thing, you know, just it's quite a nice equation. So if I have a look at subbing in for x is greater than 4, you could see this will be positive and this part will be positive. So I'm always going to get a positive when x is greater than 4. And the other thing is when x gets bigger and bigger and bigger, so when x goes towards infinity, you can see this y is going to go towards 0. So we have this nice also horizontal asymptote as x goes to infinity or negative infinity. So clearly I can see that as x gets really, really big, y is going towards 0, but also x is greater than 4 gives me a positive y. So this section I could already draw, probably. If you're unsure because you think, oh, something might happen in between, there could be some bumps and lumps in there, then another thing you can look for is any stationary points and just check for stationary points. And we can do that. So let's have a look at finding any stationary points using calculus. So we could do a couple of different things. It does say to show that y dash equals that. So we could do it using a chain rule, or so many different ways to do it. So some people would go, oh, well, that's the same as y equals x squared minus 4x to the negative 1, and you could do it that way, that's no problem. Or you could do it by using 1 over, something like that, and you could say, all right, differentiate the top times the bottom. So, you know, you could do it, as I said, all different ways. Let's do it this way. All right, so we're going to put negative out the front, x squared minus 4x to the power of negative 2, and I'm going to multiply, so using chain rule, by 2x minus 4. And you can see there that we will get, if I've still got a minus out the front, if I factorize by 2, I get x minus 2. And then on the bottom, I've still got that x. If I factorize, I've still got that x minus 4, squared, which looks like this, except we've got a 2 minus x. And of course, if I put that minus into that bracket, it becomes a 2 minus an x there. So, yeah, I mean, usually you wouldn't get given that, but you know, you can definitely use y dash, remember, equals 0, gives you any stationary points, and you can see from this, it's only going to be at x equals 2. So there's only going to be one stationary point. That is where x equals 2. And if you sub in 2 here for x, you get 1 on 2. 2 minus 4 is minus 2. So you get negative a quarter. Is that right? So this point 2, well, let's just put it here. 2 negative a quarter is a stationary point. Now you can go ahead and find what type of stationary point, or have a look at our vertical asymptotes there and just check. You know, you could check either side of 2 for the gradient, for example. Well, let's do that. Yeah, so if we put, for example, a 1 in, so I already know all that stuff, got all that stuff. So, you know, so this is quite quick if you just put it in your head. If I put a sub in a 1 into y dash, I'm going to get a positive times a positive, so it's all positive up here. And on the bottom, it's already all positive. So I know it's going to be an increasing curve. Y dash is increasing up to that point. So clearly it's going to go like that. Now what do you think is going to happen on the right? Well, it doesn't matter. Let's sub in, for example, 3. So we're going to get a positive and 2 minus 3, so times a negative on the top. So we're going to get a negative. So that means it's decreasing. Y dash is negative, so it's decreasing, which makes sense because we would have guessed that anyway. Okay, so that's that part of the curve. Now, what's the other part of the curve? That's when x is negative. Pretty easy to see when x is negative just from here, that we're going to get 1 on a negative, and then negative minus 4 is still a negative. So we're going to get y is equal to a positive. So y is always positive, and we've still got these asymptotes here. So and no turning points, right? So the only way we can think of really doing that is like a hyperbolic arm there. So that would be our curve. Now what is the range? Clearly the domain, x is not equal to 0, x is not equal to 4. What about the range? Well, also clearly for the range, you can see that a quarter is a point on that graph, but anything above a quarter up to this, so all in here, we cannot have. So in interval notation, we've got from minus infinity up to a negative a quarter, sorry, and we're including that. And then we're going from, we're going to, whoops, and then we're not going to include 0, but we're going to go all the way up to infinity. All right, so another way of saying that is just that x is between and including negative a quarter. So sorry, x is less than or equal to negative a quarter, and x is greater than 0. All right, so we found all the zeros, discontinuities. So you can use a table, or, you know, in a way, this is what I'm doing. I'm not really using a table, I'm just subbing it in my mind. So depending on the question, but more likely your question is just sketch. So showing your working, yes, the working that you needed to do, yes. And if it's you might want to do it a bit more obvious if it said show that it's increasing at this point, or show that it has a stationary point at, you know, show this stationary points. Yeah, so depending on the marking scheme, you may want to include a bit more working.